let's discuss on how to solve for the limit of this function right here as x approaches 2 from the left. Now, clearly, the denominator here will give us a 0, and thus we'll definitely have infinite limit later on. But notice as well that if we'll try to substitute 2 at its numerator, our numerator would also be 0. Remember that limit theorem states that we can't have limit of our numerator here, we're seeing this case, which is equal to 0. So we cannot have a 0 at the numerator. We may have 0 at the denominator, so as long as we can check if f of x would approach 0, if it's through positive or negative values. So in that case, we have to make ways, or we have to manipulate the terms here in a way that we should only have 0 for the denominator, and our numerator here shouldn't be equal to 0. So manipulating this part algebraically, notice that the numerator 4 minus x squared can be written with respect to difference of two squares. That is, that numerator can actually be equal to the product of 2 minus x and the 2 plus x. Now, for the benefit of others, when we see difference of two squares, so we have here difference of two squares. In this case, the squares would be 4 and x squared. Now, factoring this out, you can have an algorithm of having, yes, these factors. So you just have to get the square root of the first term. So square root of 4 would be 2. Then the square root of the second term, square root of x squared would be x. Then just have their plus and minus in between. So if we'll try to verify this one using FOIL method, that would be first term, 2 times 2, that's 4. Next would be outer, 2 times x, that's plus 2x. Then we have the inner terms, that's negative x times 2, giving us negative 2x. And lastly, the last terms, negative x times a positive x, will give us a negative x squared. So we definitely cancel the 2x and a negative 2x here. This gives us 0. So we're left with a 4 minus x squared there. Okay, so for the benefit of others, we have this in algebra. This would be difference of two squares. So going back here, square root of 4 minus x squared would be the same thing as the product of 2 minus x and 2 plus x all over x minus 2. Notice that what makes the numerator, in this case, 0, would actually be this factor right here. If we are to substitute the 2 here, this would give us 0, and 0 times this would still be 0. Gives us a hint that we should definitely cancel this one out so that we'll be left by 2 plus x, regardless whatever the denominator is, so as long as our numerator in this case wouldn't be 0. So let's do that. Let's try to manipulate this more to a point that we can get rid of the 2 minus x here. One way to cancel out that 2 minus x at the numerator is to have another 2 minus x at the denominator, right? If we have something like ab over ax, we can definitely cancel out the a's here if we have both a at the numerator and the denominator. So this is what we want to do in this expression. So we have to produce a 2 minus x at the denominator. Of course, we can have many ways to deal with this, but this can be a one way. Be sure you're friends with algebra this time with manipulating some, expressions. So as long as it's mathematically correct, then definitely that's acceptable. So in this case, what happens is that knowing that here x minus 2 is the same thing as a negative square root of 2 minus x quantity squared, right? If we have something, for the benefit of others, if we have something like square root of x squared, we can write it as just x in this case. That is, we can cancel out the radical symbol here, the square root, because this is a square root and this is already a square, so we can just cancel the squares there. So in this case, if we have something like square root of 2 minus x square, so in that case we can definitely just cancel this out, but it will give us a 2 minus x, which is that 2 minus x is definitely not equal to our denominator x minus 2. So how would we make them equal? How can we make 2 minus x equal to x minus 2? By, of course, multiplying a negative to our 2 minus x, so that would give us here a negative 2 and a positive x. There, that's why we have a sign right here. And so we're done manipulating the numerator. This time let's manipulate the denominator with this idea. So this would be now square root of 2 minus x times 2 plus x there, over a negative square root of 2 minus x quantity squared. That one. So that's the explanation right here. So it might be, this might be a bit, messy for others. So for the benefit of others, let's get some sheets of paper. So let's rewrite that one here. So that would be square root of 4 minus x squared all over x minus 2, and we discussed that this can be written as square root of 2 minus x times 2 plus x, and the denominator can also be now written as negative square root of 2 minus x squared. There. Now for the benefit of others, let's have this. Notice that 2 minus x times 2 plus x is the numerator. Yes, that would be copied. But 2 minus x squared is the same thing as square root, of course, negative square root of 2 minus x times another 2 minus x, right? Because we're just squaring 2 minus x there. Now, I hope you can remember in your still algebra or arithmetic that if we have square root of AB, we can actually have this written as square root of A times square root of B. There. So with this idea, we can actually have the numerator and denominator to be written as this. That is, our numerator can be written as square root of 2 minus x times another square root of 2 plus x. There. Now our denominator this time can be written as negative square root of 2 minus x times a 2 minus x. There. Since the operation in between the terms of the numerator and the denominator is multiplication, so definitely we can cancel here square root of 2 minus x, which what we really want to cancel out, right? Because this is what makes the numerator 0. So canceling that out, we're left now with just a square root of 2 plus x over a negative square root of 2 minus x. There. So manipulating the given square root of 4 minus x squared over x minus 2, this can be written as square root of 2 plus x over negative square root of 2 minus x. Definitely they are just equal. Now, for those who want to check it, who want to verify it, definitely if you are to rationalize our denominator, I hope you can remember that. If you rationalize the denominator, you'll go back actually to this one right here. Okay? So there. So let's have this manipulated expression back to our slide here, so we can definitely now answer the limit of this part right here as x approaches positive 2. So there. So we noted that this one right here can be written as square root of 2 plus x over a negative square root of 2 minus x. So in here, if we are to substitute this 2 right here, the denominator, our denominator becomes 0, but our numerator now wouldn't be a 0, right? So let's now apply what we had discussed in this theorem. there that we have to check if the denominator's if the denominator's function would approach 0 through positive values or through negative values. And as for the numerator, we are to check if our numerator would be greater than 0 or positive or is negative. Okay, so let's apply that limit theorem 13 to this part there. Now, we've discussed that as much as possible, let's get a number that would be close enough to our 2 here, but since specifically that would be from the left, so we can have 1.9 to consider, right? So in that case, if we are to substitute 1.9 to our x in here, that would be a positive 1.9 plus a positive 2. So clearly our numerator would be a positive 1, or that would be our c here, the limit of the numerator. If we'll go back to limit theorem 13, our c there, or the limit of the numerator, would be greater than 0. There. How about for the denominator? Now, if we are to substitute that 1.9 here, notice that our radicand 2 minus x, that would be 2 minus 1.9, would still be a positive number. But since that positive number will be multiplied by this negative number right here, clearly our denominator this time is actually a negative number. And so, positive divided by negative would give us a negative answer. So definitely the limit of this part right here as x approaches 2 from the left would be a negative infinity. So if this would be a negative infinity, we just have to check this part right here if it would be a positive constant or a negative constant, applying this theorem right here, right? If one of the limit of the functions, would be equal to a negative infinity, we have to check the limit of the other function if it would be greater than 0 or positive, or less than 0, that would be negative. Or again, in the context of operations on integers, in this case that would be negative infinity times g of x here, or that c, the limit of g of x, which is c, is positive. So negative times a positive would give us a negative. And in here, this one's negative and this one is still negative. That gives us a positive infinity here. So going back to this part, how about the limit of x minus 3 as x minus 3 all over x plus 2 as x approaches 2 from the left. Now, we can definitely just substitute x at our denominator here because it wouldn't be equal to 0, right? So the limit here would just be, for the denominator, that would just be 4, and our numerator would be a negative 1. So negative 1 divided by a positive 4, our answer here is a negative number, a negative constant. So in that case, negative infinity times a negative constant, definitely our answer here would be a positive infinity instead. And that is again based from, in here now, that would be specifically because of this theorem right here. There. So if you guys have questions again on how come we have this as an answer, or how did we arrive at some point at this part of the given, at this part of the solutions, feel free to comment down below or inform me on what part you're having hard time. Alright, so see you in my next videos. Just tell me on what slide you're still having some problems with, and I'll make some ways to have some videos on those issues. Alright, thank you guys for watching and for listening.